Good morning, dear students. In last lecture, we had seen the solution of exercise 4.1, and now we will proceed with the following explanation. Now, to start with exercise 4.2, we need to understand some properties of determinants which will help us to solve complex determinants into the simple one. Right, there are 6 properties that you should understand. We will go through each property one by one. We'll explain the meaning of it, how to use that property, and after the explanation of these properties, we'll start with exercise 4.2. Right, so your first property is Ri to Ci. After applying this property, all the rows of your determinant will get converted into columns. That's why named as Ri to Ci. All rows will get converted into columns. Right. To understand it, let's take a simple example of a determinant A, B, C, D, E, X, Y. So this is your 3 cross 3 determinant. If I apply Ri to Ci, then this determinant will be, this is your first column, will become your first row. So A, D, X. Right. This is your second row, will become your second. This is your second column, will become your second row. So B, E, Y. This is your third column, will become your third row. C, F, Z. Right. Side by side, we'll also understand that whether this property will alter the value of this determinant or not. So if I talk about this particularly this property, then this property won't change the value of determinant. If suppose the value of the determinant was x, after applying this property, the value of determinant will be x only. There will be no change in the value of the determinant. Let's move on to the second property, which is Ri to Rj or Ci to Cj. R represents row, whereas C represents column. This property says that you can interchange any two row or any two column of a determinant. Right. Let's apply this property and understand. Suppose your given determinant is A, B, C, and if I apply R1 to R2, then this property says that you should interchange row 1 and row 2, means your row 1 will become row 2 and row 2 will become your row 1. So clearly in this determinant, your row 1 is ABC and your row 2 is DEF. So row 2 will become your row 1 and row 1 will become your row 2. third row will be as it is, right? Now let's talk about the change in the value of a determinant. Suppose previously the value of determinant was x, then here after applying this property the value of this determinant will become minus x, right? So applying this property will change the value of the determinant. So to compensate this we'll keep one thing in mind while applying this property. If I apply this property, then I will change the sign of the determinant. For example, you can see that the sign of this determinant is plus. So after applying this property, will change the sign of this determinant as minus. If it was minus here over here, then after applying this property we'll make this plus. By doing so, our answer will not get changed or altered, right? So one thing you should keep in your mind while applying this property is you have to change the sign of the determinant. If it is plus, then you apply this property and then you change the sign of the determinant after applying this property, right? If it was plus, then you make it minus, and if it is minus, then you make it plus. Let's understand the third property. This property deals with the identical rows or column. What does that mean? If I have identical rows or identical column in determinant, then the value of this determinant will be 0. Why here the value of the determinant is 0? As you can see that your row 1 is equal to row 3. The same goes for column also. If you have two columns or two rows identical, then the value of the determinant will be 0. Let's understand the fourth property. This property says that you can multiply any row or any column by a certain constant. How? Let's apply this property and understand this. Suppose your given determinant is this, and I am applying row 1 is 2 times the row 1. This property says that the new row 1 obtained is by multiplying the old row 1 by 2. So your old row 1 is ABC. So you multiply that old row 1 by 2. You will get your new row 1, that is 2A, 2B, 2C. Mind well that the instruction for row 1 is only given, therefore only row 1 will change. Row 2 and row 3 will be unaltered. They will be same. So this is your new determinant obtained. Let's talk about the change in the value of the determinant, right? before applying this property, if the value of this determinant was x, then after multiplying 2, the value of this determinant will become 2x, which is not required. You always know that the value of any quantity should not change while solving the sums, right? So as the value is getting changed, we should counterbalance this, right? So what's the counterbalance process? If you are multiplying any row with that constant number, then you should divide that same constant number outside that. So here you can see that I am multiplying 2 to row 1. I should multiply that 2 outside, divided 2, sorry. If I am multiplying 2 with row 1, then I should divide that 2 outside the determinant. So if I divide it by 2, then I will get the same value x. So what's the counterbalance? If you are multiplying any row or any column by a constant number, then you divide that constant number outside. And if you are dividing any row and column with a constant number, then you multiply that number outside the determinant. You have to do the opposite process. If I am multiplying, then you divide it. If I am dividing over here, then you multiply it. Let's understand the fifth property. Fifth property deals with the splitting of a determinant. Means, suppose the determinant is written in this form: a plus b plus q, c plus r, d e f x y z. Then I can split this determinant into summation of two determinant as a, b, c, d, e, f, x, y, z plus p, q, r, d, e, f, x, y, z. You can see that row 2 and row 3 are same in both of this determinant, only their row 1 is different, right? Reverse is also possible. If two determinant has two row same, then you can add the third corresponding row, right? Then answer will be this. Means you can go from left hand side to right hand side, and you can also go from right hand side to left hand side. Both is possible. Let's understand the sixth property and the last. This is the last one, very important, and this will be used most of the time to solve complex determinant into the simple one, right? We'll understand by applying this. This property says that you can multiply any row with a constant number and then add it into the another row to obtain the new row. Let's take an example. R1 gives R1 plus 2 times R2. Right. This property says that you have to multiply row 2 by 2. So your row 2 is DEF. So you multiply that by 2. Each and every element of row 2 will multiply with 2. And add it with row 1. Your row 1 is A, B, C. So if you add them, then you will get A plus 2D B plus 2E, C plus 2F. The resultant obtained will be your first row. You can see that over here the information about the row 1, new row 1 is only given. Therefore, our row 1 will change. There will be no change in row 2 and row 3. Row 2 and row 3 will be unaltered. D, E, F, X, Y, Z. Only your new row 1 will be A plus 2D, B plus 2E, C plus 2F. Right. If we talk about the change in the value of determinant, then this property won't change the value of determinant. Means if earlier it was x, after applying this property it will be x only. Let's start with the very first sum of your exercise 4.2. Here they are asking us to find the value of this determinant without actually expanding it, right? So using properties we need to find the value of this determinant. Here we will try to apply that third property, which says that if any two row or any two column are identical in the determinant, then the value of the determinant will be 0. So here we need to see that can we make any two row or any two column identical by applying any property. So you have to observe it very carefully. You can see that here it is x plus a, y plus b, z plus c. Here it is x a, y b, z c. So if I add column 1 and column 2, this property says that the new column 1 obtained is a result or the summation of column 1 and column 2. So column 1 plus column 2 will give me x plus a, y plus b and z plus c, and the value will be kept in column 1. So I have keep that values in column 1 only. Column 2 and column 3 will be unaltered, and as you can see that your column 1 and column 3 is identical, the value of this will become 0. You can see that, you can say that because your column 1 is equal to column 3, applying property